There's a principle, an overarching principle in sampling science that materials of varying size and varying densities never fully blend to homogeneity. We're dealing with particles that are very heavy, precious metals, and we're dealing with particles that are inherently very light, whether it's carbon or other light elements. If we can separate the two at this stage, then we're going to be producing a much more uniform product, which would be the fines fraction, that'll continue into the next step of the operation. When dealing with any kind of sweep processing, there will most always be two fractions to reconcile. You'll have a metallic fraction and you'll have a fines fraction. The standard range at which most refiners are screening material through will be anything in the area between like 40 mesh and 100 mesh. 40 mesh being the larger. That's sufficient for lower grade materials, things like electronic scrap and that type of feedstock. As you start to get into materials that have a higher precious metal content, then you ultimately want to go to a smaller screen size. There's another approach that can be taken using these test sieves, which are used in sample preparation as part of the laboratory function. One of the ways that you can strike a balance between having something that can be done at a reasonable production pace, but then still provide something with the lab that is a very uniform product, is you can take a bulk sample and then take that sample and then continue to reduce that in a laboratory mill and then start to get down to even smaller mesh sizes like 100 mesh or even smaller. And that's a very practical approach as well for things that are very high grade.